Hello, welcome back. So in this video, I'm going to present it how I use software ImageJ to measure the area and average area of grain microcrystal of metals. And also I want to show you all how to measure the length, diameter, and also the area of indentations picture of hardness tests using ImageJ softwares. So uh, I will explain a little bit of ImageJ. So ImageJ is basically a software to measure the picture of microstructure of metals. And not only that, ImageJ oftenly used to measure the diameter, length, and also the area of indentations. The one like we used to measure the indentations of hardness of Brinell, hardness of Pickers, Rockwell, something like that. So let's we share screen, remove this, and let's just directly open our ImageJ. Okay, now we have what we call a menu bar. So let me put it a bit to the center. So in this menu bar, we're going to press File, Open. In here, I have a couple of pictures of my previous metal hardening test. This is one of the picture. This is the microstructure of AISI1045 that commonly we call as carbon steel with the composition of 0.45 of carbon in it. So how we measure all the area of these grain crystals of the metals? So ImageJ help us with the feature of measure. So we choose line and we have the scale bar here. Usually when you're taking a picture of microstructure from the microscope, you will have a scale bar to measure the size, length, and also the area of the microstructure grains as the scale. So we make a line here and then press Analyze, Set Scale. So in the pixels of this picture, the distance is 66, and we put the known distance that we are desire. The distance is 1, and the unit is microns. Now we press OK. Now the scale is 1 microns. Let's take an example like this crystal grains. We press Analyze and Measure. You see, the length of these crystals almost in the y-axis. Yes, in the y-axis. It's 1.632 microns. And how we measure the area of these grains? We just press freehand selections, press left click, and hold it. You draw the line along the grain boundaries. Yes, the name is grain boundaries. And press Analyze, Measure. So now we know the area of this microstructure grains is 1.423 microns square. micron square. That is for area. So, what is the average of all of this crystal? Yeah, that means you have to uh, make something like this and use the different grain crystals. And anywhere you like. So, more of the measurements that you conducted, that means the average of that you will get is way more precise because the amount of data that you have will be more. So, and also, I forgot to mention about this. You can copy this and then paste it in the Excel, in the Microsoft Excel. So you can create a plot of data that you are desire. Not only that, one of the features that I want to show is um, image and adjust threshold. So in this threshold, it commands me to make split channels. Basically, it's more like a different picture format so that uh, it can be transformed the color. So I will explain why I should um adjust the threshold. Press color, split channels. Now we have the different formats. Press image, adjust threshold. So this is what I want to show. This is the window threshold. You see, uh, the color can be red, black and white, over or under. Nah, I'm usually use over or under and uh, red. So threshold is telling us which grain color is brighter and which one is darker. The darker in this area, that is the grain boundaries, and the red one is the grain crystals. Now we want more precise calculations. That's why we choose the red area so you can be more precise following the black area, only the black area that you are measures as uh, as the example for calculations. Not you're not doing it like this on the red area because you want to sizing the crystals. Now you can adjust the redness and also the blackness of uh, the color of the picture. Usually this is already more than enough. You can adjust all you want for the focus of the color, and that's it. It's just threshold is just basically to differentiate the colors, bright and darker, so that you can measure it way more accurate. Another thing that I want to show is I usually measure the indentations diameter of hardness Brinell test. So this is the results of hardness Brinell test. You see that this round hole is created from the indenter of a tungsten ball. So how to measure it? You see that there is a scale bar here. So you can pull the line and then press analyze set scale. The distance in the picture here 127. So every 127 pixel, the size is 200 microns. Press OK. Now we're sizing the diameters. For the diameters, you can just line, and then press analyze and measures. So this is the diameter, the length, the diameter of the indentations. That is 346.188 microns. So what is the equations of Hartness-Brinell number? Hartness-Brinell number equations. Let's search it in the Google. Brinell hardness number formula. Nah, you see, Brinell hardness number requires P caps lock D and small d. The caps lock D is the diameter of the indenter, that is the diameter of tungsten ball that been pressed to the sample. And the small d is basically the diameter that we measure, the diameter of this hole that is 300 something like that microns. So this function is very crucial for the calculation of Brinell hardness. So basically, um, this is the one of the crucial value, and image J tell us the value of indentations hole diameters. So that is one of the function of image J that I like. And that is how I use image J to measure of the wide area of grain crystals, and also I measure the diameters of the hole indentations, etc. And that is what I want to show how I use image J. We don't have to save this, close the menu bar, and that's what I want to show you all today. Thank you for watching and have a great day.